Okay, well, thank you. Let's see. So if you're like me, you started out using blending modes by basically going through the list that was available in your software until you found one that kind of did what you wanted, and then just went with that. That's what I did for a long time, and eventually I started stumbling across information about how blending modes work, and it's done some incredible things for how I use them and how I do cartography in general. So I would like to share some of the things that I've learned in order to hopefully help that journey be a little faster for you. So first, what exactly is the deal with blending modes anyway? Well, if you use transparency to blend two layers together, the colors in those two layers will be blended evenly, completely ignoring what those colors are. What blending modes do is they are a way to selectively mix colors based on what those colors are, and the different modes are different methods for doing that. So for example, multiply, a pretty common mode, it makes white completely transparent and black opaque. So this is really good for simulating the addition of ink to a page. Using a multiply mode is almost exactly like printing out that layer on a sheet of plastic and then laying that plastic over a printout of whatever's underneath it. Screen is the opposite of multiply. White is now opaque, black is completely transparent. This is really great for lights and luminous effects. And then hard light does both of those at the same time. Now white is opaque, black is opaque, black is opaque, and the medium grays are transparent. So that's really cool if you're trying to add shaded relief to a map, because if your flat areas are medium gray, they will completely disappear and you only get the highlights and shadows from your shaded relief. And if you compare that to transparency, you can see that it's a much nicer result. So how do blending modes work? Well, does this come off? There we go. Hopefully I can avoid the sound cutting out. So on a computer monitor, or maybe not, on a computer monitor, we represent color with additive primaries, red, green, and blue. And as we vary the amount of those primaries being used, we get all the different colors that we can display on a monitor. Now, normally, oops, I skipped ahead there. Normally, we represent these amounts of the different color channels with a number between 0 and 255. But in the context of blending, we use numbers between 0 and 1. And then, so let's take a pair of sample colors and look at what's happening when we blend them using the multiply mode. First, we split the colors up into their component channels, and then we're going to apply the blending operation. And you can sort of think of the blending operation as a sort of preset raster calculator operation. And in the case of multiply, it's exactly what it sounds like. You just multiply the value of A with the value of B. But it's important to notice here that the separate channels are blended separately, not with each other. Red is blended with red, green with green, blue with blue. They're not mixed. And that will be important later on. Once the blending operation is performed, the channels are recombined to produce the resulting color. Now, having said all that, I should point out there are 4 blending modes that you see in a lot of different software applications that don't work this way. Hue, luminosity, color, and saturation. They work on a completely different mechanism that I unfortunately don't have time to go into here. But I do have a reference document prepared that I'll be linking to that does go into how these work, or at least what they do. So that covers what is happening when we're blending 2 colors at a time, but that doesn't really help us that much because we'd like to see what would happen for many combinations at a time. Ideally, any arbitrary combination of two RGB colors. But that's not really feasible because there are so many different combinations of two RGB colors that if I tried to put them all on a monitor, 1 pixel per color, that monitor would have trouble fitting in the bay outside. So we have to take a different approach. If we go back and look here, remember each channel is blended separately, which means we can get away with looking at one channel at a time. And since all the channels are blended in the same way, we don't really care what channel we're working with. We can just represent these with shades of gray. And that lets us work with these, with a couple of grayscale gradients to make a chart of the different results of a blending operation. So here I represent the possible values of A with a vertical gradient from black at the bottom to white at the top, and the values of B with a horizontal gradient, black at the left to white on the right. When I place the A gradient over the B gradient and set it to a blending mode, I get a chart of all the gray values that you can get from blending A with B when it's set to multiply. And in fact, you can make these charts for any blending mode, and every different blending mode will produce its own unique chart. And the interesting thing about these charts is that if you know how to read the patterns on these charts, they will tell you everything you need to know about how that blending mode is going to behave. Everything that I said at the first part of this talk about multiply, screen, and hard light is visible on the charts in that left column there. You just have to know what you're looking at. Unfortunately, I don't have time to go into how to read these charts. So what I've done is that I've set up a reference document that goes into making these blending charts, how to read the patterns on them, and it's also got a list of all the blending modes, at least the ones released in ArcGIS Pro, along with the charts for each of those blending modes and their formulas and a few words on things that you can use them for. And I'll be putting this QR code up again at the end of the talk if you've missed it. So for the rest of this presentation, I'd like to convince you why these charts are worth your time, because you may be thinking, okay, well, there's these charts up here, and I have to just learn the language of how to use them. Is that actually better than just picking blending modes and trying to learn how they work some other way? My opinion on that is absolutely yes, and I'm going to show you a sort of personal anecdote of how that can be the case. This is not going to be a step-by-step how-to. It's just going to show you something that I did that never would have occurred to me without these charts. So for years, I struggled to understand what the deal with exclusion was, and this is its blending chart up here. And I was looking at this chart and I realized, you know what? This actually kind of looks like the pattern that you get for something like a multiplication table where the values go from -1 to 1. It is upside down, but that's actually a minor complication. So this is what I realized is what exclusion's deal is it lets you pretend that your color values, which usually go from 0 to 1, actually go from -1 to 1 and multiply them. It lets you pretend that you're multiplying with negative numbers in Photoshop. So that got me really excited because there's a whole bunch of different things you can do with that, including running a dot product on RGB rasters. Now, back in 2019, I did a talk on a type of RGB raster representing surface orientations and what you can do with them. And anytime you do hill shading, you are performing a dot product. One of the things that's happening under the hood is that you're performing a dot product between the surface normals of the terrain and the lighting direction. And one of the ways that you can represent the surface normals of the terrain is this type of raster on the left here called a normal map. I published a paper in them in Cartographic Perspectives issue 96, normalizing the normal map. They're really useful. I highly recommend looking into them if you haven't already. But if you can do a dot product between these RGB rasters, and the exclusion and luminance modes allow you to do a dot product just with blending modes, that got me thinking, well, maybe you can do hill shading just with blending modes and not having to use any actual tools. And if you can do that, maybe it could even be dynamic. And so I set up a map in ArcGIS Pro to test that. So here is my normal map of Mount, oh, we're not actually looking at that on screen. 1 second. Okay, yep. Okay, so this is my normal map of Mount Hood in ArcGIS Pro. And on top of that, I have again, it uses RGB colors to represent surface orientation. It's like a slope aspect map, but it uses the components of the normal vector instead of the slope and aspect angles. I have another raster here that uses a similar concept to represent lighting direction. The nice thing about using a raster for your lighting direction is that it can be variable. This one represents lighting direction as if it's from a point light source hovering in the air above the mountain. And if I go and set this to exclusion and then turn on a couple other layers I have for corrections, I do actually get my hill shade on the mountain as if it's lit from a point source hanging in the air. And the cool thing about this is, again, it's dynamic. My light source raster is on a graphics layer, so I can just grab and move it around, and the light updates accordingly. So this is a little bit of a gimmick, but it still highlights some of the really cool things you can do with blending modes, and it never would have occurred to me to do this without looking at that blending chart for exclusion. So hopefully this reference document will be useful to you in your own experimentation and exploration of blending modes. That's pretty much all I have for you today, and if I've left any time for questions, I'll be happy to take them.
Give it up for Charles. Yes, we do have time for 1 or 2 brief questions, so raise your hand if you have something to ask. Carl?
So the exclusion chart kind of, I had a question before that, but then it really made me think that maybe that chart answers it, which is oftentimes I'm dealing with large stacks of rasters, and I want to blend them together to produce some sort of like composite result of, say, 1,000 rasters of like snowfall. But obviously that's going to wildly blow out any blending mode I use on it or transparency. So my initial question was, to what level of precision does Photoshop handle like combining different layers? Like, can we go to like 0.001 of that 0 to 1 range? But then I thought, with that exclusion chart, would that be a way of getting double the amount of potential values?
It depends on the order of operations that the app in question is using, and it also depends, in the case of Photoshop, on the bit depth of your document. So if you're using 16 bits for your grayscale, it actually has a lot more precision than it would if you were using 8. So for example, these charts were made with 16-bit grayscale gradients, which is why that contour that gets smeared out in the middle looks as smooth as it does. If you try that on an 8-bit image, it looks much worse. But you can also do a lot of interesting things, especially in 32-bit mode. Like Photoshop is kind of funny this way. It won't let you enter a negative number for a grayscale color in the color picker. But if you use modes like subtract, you can still get negative numbers out of it in 32-bit mode. So it is a little bit weird. And again, it's definitely something that rewards a lot of experimentation and playing around with it. But yeah, that would actually be something good to talk about after the session's over.
All right, I think that's it. Give it up for Charles, everybody. And if you have more questions,